Hi, so we're going to conclude this chapter with outliers because outliers are influenced by the data itself, right? So recall that if there is a data far outside the scope of the model, like really low or really high, that will affect the calculated average or the mean, right? But it didn't affect the other central tendency of median, right? Because the middle is just the middle. So because outliers can influence your data and kind of weigh it down or up depending on what type of data it is, it's appropriate to talk about outliers because if we talk about significant relationships, there might be this outlier where the relationship is outside of the scope of the model. So there's a couple of ways to think about this. Outliers are observed data points that are far from the least squares line. So if I have this least squares line, right, and I have a point really far away, right, that because the distance from that line, the predicted value to the observed value, right, is so far and all the other points are really close to the line and then we have one way out here, that would be an outlier. We're also going to discuss a different type of point. It's called influential, and that's a little different, but it's the same idea. But the outlier in this chapter would be where you have this regression line and you have points in a certain pattern around the line, and then you have one that is far off the line and off the pattern, and that's what we call an outlier. Okay, so again, they have large errors, and the residual is the vertical distance from the regression line. So just like that, y hat or y minus y hat. So as a rule of thumb, we can flag any point that is located further than 2 standard deviations. So recall that 2 standard deviations is the 95% 95, 2 standard deviations is 95% of the data, right, from the empirical rule. So we like to do a 95% normal probability plot. To do the normal probability plot, specifically for a 95% interval, that you would need a higher or more like powerful statistical software like R or Minitab or SPSS. We are only going to be using our calculator in Excel, so we're just going to be doing the normal probability plots that we have been doing in the previous sections, and also some residual plots as well. So I just want you to know that when we say 2 standard deviations, we like that 2 standard deviations, but in order to do those plots, we would probably need a more powerful statistical software. But our calculator is pretty good anyway, so I think we'll just use that. Okay, so the first thing we'll want to do is perform a residual analysis on the model. So we want to do a residual analysis because a residual, recall, is that difference between what's on the line and what's on the line and what's observed, right? It's that distance. And if we take one that's really far out there, right, we're going to be able to grab that distance to be very large and then call it an outlier. So we can go ahead and kind of scan through all these residuals, all these distances from the predicted to the observed, and kind of determine if there's an outlier. Now, we're not going to do that because in real life, we get like hundreds and thousands of pieces of data. So we're just going to have a calculator do it for us. So and the reason we do this is, and I put a couple of bullets here, so is to determine whether the linear model is appropriate, determine whether the variance of the residuals is constant, and we like to check for outliers. So it's really important to note that just because we have a high correlation between two variables, it doesn't necessarily mean that a linear model is appropriate. It could be just some other model like exponential or logistic. So we want to make sure that when we have the residual plot that we show like a pattern um, that's not linear related. So if we get a pattern that's a curve, then we realize that it may not be linearly appropriate, but maybe some other type of model. So if we get a curve or like a zigzag, then we realize that this isn't going to be a linear model, that we should be looking at maybe a different one like quadratic or logistic and so on. Okay, so to do a residual plot, I went ahead and put like the calculator, like entering the raw data into lists, right? Explanatory response. You'll obtain the least squares regression line. And then you'll do stat plot and then plot one. And then you'll go ahead and put the list explanatory variable in list one. And in Y list, you'll put residuals. So notice your calculator already knows that there's residual plots in there. And so all you have to do is, instead of putting the response variable in Y1 or Y, that all we have to do is put resid. And we just get there by hitting second stat and then under names put resid. And then we do a zoom stat. So we're going to look at this nice little plot. Okay, so let's go ahead and do that. So in this example, a chemist has a 1,000-gram sample of radioactive material, and the chemist records the amount of radioactive material remaining in the sample every day for a week and obtains the following data. Here are the days and here are the weights. And on the next page, it says draw its scatter plot with the least square regression line. So that's one thing. We'll use the linear coefficient, or find the linear coefficient, and use a residual plot to determine whether the linear model is appropriate. And then we'll round to 3 decimal places. So we can see that there are a few things we're going to do. We're going to do a scatter plot, we're going to find R, and then also a residual model. So the first thing we'll want to do is go ahead and put this data in your calculator. So go ahead and go into your calculator and go to Stat, go to Edit, and in your list 1 and list 2, you should have that drilling example from the previous sections that we've been using since the beginning of doing scatter plots. Keep those in there. Do not delete them because we're going to use them again. So I've been keeping them in there as list 1 and list 2. So I'm going to put this data in list 3 and list 4 and use those two as my explanatory and response. So you can see here, you can pause the video to go ahead and enter this data, but I already have done it, so go ahead and pause and take a moment and enter them in. And so the first thing we'll want to do, let me go ahead and scroll down, is we'll go ahead and put list into calculator, calc. Step 2, we'll go ahead and do a scatter plot and run a linreg. Okay, so let me go back to the calculator, and I have list 3 and list 4, so let me go back to stat and let me go to calc and then number 4, the linreg. And in my X list, you'll put in list 3, and my response variable was list 4. I don't have a frequency list, and I'm going to go ahead and store this regression equation in Y1. So I'm going to go to vars, yvars, menu, function, and I'll select Y1. And then I'll go ahead and calculate. So I'm going to drag this over and then hit calculate, and then there is, okay, so we could see here that, let me get my highlighter, that R is negative 0.994. So in the back of our head, we note it mathematically, that's a numerical number, but in relationship to the day and the weight in grams, depending on how many days passed in that week and how many grams of what is it, of radioactive material has dissolved, this is a very strong negative correlation. Right, that's a pretty strong, and that's almost exactly a negative correlation. So we assume there's going to be this strong linear relationship, right? Okay, well, let's go ahead and run a scatter plot. I think that would be the next thing. Let's see if it is. So the third thing we'll want to do is go ahead and draw a scatter plot with regression line. So now let's go ahead and go to our calculator, and we will go to second stat plot, and maybe let's click y equals, and we can see that that regression line is there. So let me clear this one out, and then you could see that there is my regression line that matches my A and my slope and my y-intercept here. So let me go ahead now. That's good to go. It's going to draw the line. So let me go to second stat plot and put my plots on. Hit on. And I'm going to draw a scatter plot, which is this first one. My X is list 3, and then hit enter. My response variable is list 4. And I'll go ahead and mark the markers blue, and then I'll hit zoom stat, which is zoom 9. And so notice it gives this really nice scatter plot. Let me drag it over. And so we can see from the picture that this looks like almost perfect linear relationship. Right? That looks like, look at that. Boom. It looks like they're all lying on that line. Okay, so at this point we see the R is close to -1. We think it's a strong correlation. We see the scatter plot with the line, the least square regression line, and we think, okay, this has to be a linear relationship. But how do we really know? Well, this residual plot, what we're going to do with the residuals is we're going to calculate the difference between every observed to the predicted, right, that vertical distance, and we're going to plot them. And if they make a pattern other than some sort of line, linear line, right, if it's a curve and it's a distinct pattern, then we know that the line is not the appropriate model, that there is an appropriate model out there, but it's just not going to be a linear one. So let's see what happens. So let's follow the directions in the calculator. So the last step is we're going to do a residual plot. So now I'm going to go ahead and go to the calculator and kind of go through the same process as I just did. And I'm going to go to the y equals, and I'll go ahead and second stat plot on. I'm going to go to the same thing, but now y list has to change. Right? Y list now becomes second stat. And notice number 8 is resid. Okay, so again, second stat gives you the names, and then it'll take you to resid. So it should look like similar to the regular scatter plot we just did, except the y list will be resid, and then we can go ahead and plot this. But before we do, let's go to y equals and turn this line off. So go highlight the equal sign so it's blinking and hit enter. And then notice that it's no longer highlighted. Now let's go ahead and go to zoom 9, which is zoom stat. So you can see the residuals here, and these again, this isn't the scatter plot, right? This is that distance. Let me go to the scatter plot. This those are plotted the distance from the line to the observed. So see how the squares are a little off from the line? Well, I just took every square and subtracted the predicted value, which is the y value on that same x value, and plotted those differences. And when I plotted the differences, I got this graph. So these are going to be the residuals, meaning the differences between each observed value and its corresponding predicted value. And so now we could see that this does not make a linear relationship. In fact, this is a distinct pattern, distinct curved pattern. And what this is this implies a linear model is not appropriate.